Hi friends, today we are going to see a new chapter, Infrastructure as a Code, IaC. It is a Terraform class. If you look at almost 10 to 15 years back, most of the IT infrastructure deployment are done manually. Whether it is a small infrastructure or a big infrastructure, everything will be done by manually. There is a lot of engineers will be there. Server admin, network admin, storage admin. So a lot of people will be working in the IT infrastructure team. So they manage all the IT entire infrastructure manually only. For example, there is a new application is a new project is initiated. The business analyst will connect with the business leaders like directors, VPs. They will connect the business need, and then the business analyst will share the information with the solution architect or technical lead. The solution architect will define the infrastructure, how many servers need, what are the network devices we need, how many networks we need to configure, how many VLANs we need to configure, what type of server we have to configure. So everything will be defined by the solution architect. And then it will be given to the procurement team. Procurement team will respond for purchasing the physical servers. They will place the order for physical servers. So solution architect will define the architectural diagram. He will define how many servers, how many network devices, how many application are, what are the type of voice need like this. He will define the entire thing and give it to the procurement team. So the procurement team will purchase the physical, all the physical servers, network devices, cables, everything they will do. And then they will be given to they will hand over all the servers network device to the field engineers. The field engineers will be responsible for mount the servers in the rack, mount to the network device in the rack, cabling, everything will be handled by the field engineers. So they will receive the servers, check the configuration, check all the physical components are working fine, and then they will mount the server in the racks, connect the power source, networking, cooling, everything they will do it, and they will power up the servers. When the server is up and running, it will hand over to the system admin team and the network admin team. So system admin team will handle the OS installation, partitioning, patching, everything they will do. Network team will handle responsible for assigning the IP address, network segmentation, network connectivity, firewall rules, everything they will be handled by the network admin team. And then storage admin team and backup admin team will be there. They will handle the storage. They will connect the servers to the storage. NAS box, sandbox is there. They will connect the all the storage boxes to the servers, and they will create the file shares. Backup team will respond for configuring the backup policy, running the full backup, incremental backup, differential backup. They will respond for handling the backups. And finally, the server will be handed over to the application team. Application team will they will install all the application dependency tools, framework, SDK, everything. So everything will be handled in manually. So it will take lot of time. If you look at the this kind of manual deployment, the drawbacks are slow deployment. For example, if you place a servers to HP or Dell server, if you place a order for servers, physical servers, it will take 2 to 3 weeks for the delivery. Once the server is received, it will be mounted on the racks, connected to the power, cooling, networking, everything. Then OS installation, application installation. It will take another 1 month. So deployment will be very very slow, and it is very expensive. The company has two applications. One is in .NET, another one is in PHP. We can't run the both applications single server. For the .NET application, we need Windows servers. For the PHP application, we need Linux servers. So it is very expensive. Unlimited automation. The automation part is very very limited. Maybe for running the backups, they will write the script. Apart from that, most of that are manual only. And human error. There is a chance for misconfiguration, mishandling the servers, misconfiguration in the network devices. So, a lot of human error will be possible, and then wasted resources. The company purchase, if a company is running 6 application, if they purchase 6 servers, most of the services are underutilized. Maybe you consume only 20% of the total resources. This okay, that is underutilized. That is wasting the resources, and then inconsistency. For example, if any one admin, if any server admin is right now working, or any solution actor technical lead is working, he prefer HP servers. So he will buy all the server will be HP servers, same configuration. All will be running in Windows. The person if the new person is coming, if the new person is prefer Linux, he will and he prefer Lenovo servers. He will go to Lenovo servers. He will install the Linux OS. So if you look at the IT infrastructure, and all the servers are equal. Some servers, some tower servers, some rack servers, some blade server like this. The different types will be there, different configuration. So there might be an inconsistency. So these are all the drawbacks in managing a infrastructure in manually. In traditional infrastructure, one infrastructure requires a chain of manual handoffs. There might be a lot of team, server admin team, network team, backup team, storage team, technical lead. Several teams will be there. Everyone has a separate role in that one. Each team complete a separate step before the data center is ready. So it is slowing delivery and increasing the chance of inconsistency. As we already knew, so business leaders, VP directors, they will share the business required capacity. The business analyst will identify the needs, clarify the needs, give it to the technical lead. Technical lead will design the solution and hand over to the procurement team. They will hand responsible for sourcing the hardware components. Then it will be hand over to the infrastructure team like servers, network team, storage team. So infrastructure team consists of several people. They will coordinate all the special activity, installing OS, configuring networks, everything they will hand, deal with. So the service manager in the data center. There's slow deployment, higher cost, limited automation, human error, wasted resources. These are the drawbacks in manually deploying, configuring, managing the IT infrastructures. So to overcome this one, this infrastructure as a code is came into picture. So what is infrastructure as a code? Infrastructure as a code. IaC is a practice of managing and provisioning the IT infrastructure. It is a practice of managing and provisioning IT infrastructure such as virtual machines, network, firewall, storage, and load balancer using mission readable definition files rather than the manual interaction tool to hardware configuration. Instead of manually doing all the things, OS installation, configuration, provisioning, managing, monitoring, backup, everything. So we can write the code in Bicep, in Terraform, and Ansible. So you write the code in files and keep it in the version control system like GitHub, and then we will provision the cloud resources through the GitHub repos through this IaC templates. By treating infrastructure as a software code, organization can apply standard software development practices like version control, peer reviews, CI/CD, automated testing to their physical and cloud infrastructures. So these are the ways, the benefit of managing the IT infrastructure through the infrastructure as a code. So we have a version control. We keep all the coding files in GitHub, and it will be reviewed by the peers, colleagues, team members. Even if you trigger the CI/CD pipeline to deploy the cloud resource on Azure AWS, you should be they have to raise the PR pull request. The pull request PR should be reviewed by the senior team members. They have to approve it. Then that will be deployed in the dev environment. If it is successful, then this dev branch is merged with the QA branch. Then it is deployed in the QA branch, QA environment. If it is successful, then it is merged with the prod and deployed in the prod environment. So keeping this infrastructure as a code in version control system like GitHub, and reviewing by using peers, team members, and triggered using CI/CD pipeline, and then it will be automatically tested. So these are the core benefit of infrastructure as a code. So in the infrastructure as a code, we can manage the entire cloud infrastructure. We can manage all the cloud resources with the code, not the clicks. As I already told you, infrastructure as a code is the practice of managing and provisioning the IT infrastructure like provisioning servers, provisioning network, provisioning databases, provisioning virtual machines, and other cloud resources instead of manual configuration through the web console. If it is a manual setup, we have to log in the console or AWS management console or Azure portal, portal.azure.com or GCP console, console.cloud.google.com. So we have to log in the portal and deploy the resources. With IaC like Terraform, we define everything in the code in Terraform modules, in files. Then we will trigger the initialization and then apply and then deploy. Initialization, planning and apply. So here in infrastructure as a code, the setup is repeatable, reviewable and easier to change without rebuilding everything by the hand. This is one of the benefit of IaC. So IaC makes infrastructure faster to deliver and easier to trust. If you keep the infrastructure through the IaC Terraform templates, the code turns repeatable cloud setup into a shared reviewable process instead of collection of manual steps. If you look at the benefit of IaC infrastructure as a code, we can move it faster. See, if you want to deploy 10 servers in Azure or AWS GCP, we can do it within 5 minutes with the help of IaC. So your automation, create the infrastructure in minutes. If you want to deploy 50 servers or 50 apps, 50 databases, we can do it in a few minutes through this Terraform modules. Scalability. We can increase or we can reduce the number of cloud resources. Second is stay consistency. So all the cloud resources will follow the rules. They have the name, they have the standard naming convention. Everything will be in the consistent way. So same configuration in dev, test and prod and repeatability. So all the server will be the same size, same configuration and reduce the risk. Then, so one of the benefit is reducing the risk. Since we keep this infrastructure code in the Terraform modules in GitHub in Vessel Code system, we can keep track of all the changes. If someone has opened the GitHub repo and go and make changes in, if they want to save the changes, they have to raise a PR, pull request. The PR should be reviewed by the senior team members. Once they approve, it will be, or we can measure the change. So human errors will be very, very less. So the bottom line is the infrastructure team can build, review, reuse, and change the infrastructure with the same discipline used for application. So if you look at the infrastructure as a core tools, these are the tools we will use as a IaC tools. Docker, Ansible, Terraform, CloudFormation, Packer, Vagrant, Salt, Strong, Puppet. So next class we will see in the type of IaC tools. Thank you.